Okay. Actually, this quadratic equations you have learned in your O levels too. You drew quadratic graphs and quadratic equations you solved. The same concept, but we go more deeper in the lesson. Right. So then I thought of starting the lesson from your O level knowledge. That means under O levels, dear students, you drew graphs. One question is the graph, no? It's very easy question, no? So that is the basic knowledge or the basic plot where we start this lesson. Okay. Yeah. So then before going to this A-level part of the lesson, I supposed to do a little part in the O-level you did, because that is very much important. So then soon after today class, now you drew graphs in your O-levels, no? That graphs, of course, you prepared the table and you took a graph paper and you drew that graph, no, people? So that graph, of course, by the end of today class, I think you can draw within 30 seconds. That same graph you can draw. Then people, before going to the A-level part, of course, will do something which is coming under the O-level knowledge. Then we can give an easy access to the deeper theories in this lesson. Okay, right. Then people will start. Our heading is quadratic equation, right? Quadratic equations is the heading. This is our heading, people. Okay, right. Now, under these quadratic equations, first thing we have to learn about quadratic functions. So therefore, our subheading is quadratic functions, right? Write down subheading as quadratic functions, right? People, now I'm going to consider one quadratic function, right? The quadratic function is this: y equals x squared minus x minus 6, right? This is known as, people, quadratic function. Here, its right hand side we have x squared term, x to the power 1 term and constant. We have second degree polynomial. Left hand side we have y. This kind of function only, people, we defined as quadratic function. Quadratic function, right? Its right hand side we have second power of x, first power of x, and a constant. Left hand side we have only y. This type of equation or function is called as quadratic function. Quadratic function. People, you know, in your O levels, for this kind of equation, you drew a graph. Can you remember that? Yeah. There you prepared a table and taken a graph paper, drawing y-axis and x-axis, right? You plot the points and using your sharp point of the pencil, you smoothly joined all the points. Smoothly joined all the points. Okay. And you drew the graph. Now today I am going to draw the graph this first using your method. That's why I said you, I am little bit starting from your O level. Yeah. People, I am now going to prepare a table for this. Right? Yeah. Now, then we'll write first heading as quadratic equations, quadratic functions. Then we'll come to first one like this, people. Write down like this. Under quadratic functions, write down, draw the graph of the function y equals x squared minus 6 minus 6. Right. Y equals x squared minus 6 minus 6. Right. So now, people, I am going to prepare a table in this case to draw this graph. But after another 1 hour, people, you never draw a graph, this a table, you draw the graph without considering any table or anything, right? We'll see, right? So now into this table, people, I include these three values for x and y. In this way, people, when we learn this lesson is very interesting one, very interesting one, and very easily lesson, right? Suppose this is our x, this is our y. Now I include into the table minus 3, right, this way, minus 2, and minus 1, and 0, 1, 2, 3, and the next one, people, we include here 4. Right. Now I'm going to find for each of this x value, substitute them here, the corresponding y value. Okay, right. So then x equals minus 3, people. When you put here, what do you get for y? Y come in as minus 3 perfect squared minus 3 minus 6, right? Then you get, what do you get there, people? Minus 3 squared is plus 9, and here plus 3 and minus 6. Then we get y as 6. Y is 6. Here we get 6. Okay. Like that, we can fill the other cells in the table. Right. These cells you can fill. Right. If I take another one more, x equals minus 2. X equals minus 2. Put that way here. What do you get? Y equals minus 2 perfect squared minus 2 minus 6. Y equals here plus 4 plus 2 minus 6. Then we get y is 0. This is 0. Okay. Now this way we can fill this table. Okay. Right. So then I'll write, people, the y values corresponding to each of these x. Right. So then these are the values we get when x equals minus 1, y becomes minus 4, x equals 0. This way, x equals 1, it's minus 6, 2 minus 4, and again 0 and 6 coming. These are the values of y we got. Right now, 6, 0, here we get minus 4, minus 6, minus 6, minus 4, 0, 6. Right. Now, we'll see how to draw this graph. Right. So we need y-axis, y and x-axis, and in this OXY Cartesian coordinate plane, people, now we'll plot these points. Right. So I'm going to take that now. We need the x from minus 3 to plus 4. Y is running from plus 6 to minus 6. Right. So then I mark them here like this. This is your y-axis. Right, this is your x-axis. This is your x-axis. Minus x-axis. Right, this plus y-axis, right? Here, minus y-axis, right? Now suppose here 1, 2, 3, 4, 5, 6. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. 1, 2, 3, and 4. 1, 2, 3, 4. Right. This side minus 1, minus 2, minus 3. Minus 1, minus 2, minus 3. Okay. These values 1, 2, 3, 4, 5, 6. Right here. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Right. Okay. Now people will plot the points. When x equals minus 3, y is 6. X equals minus 3, y 6 means this point. Right? This point. You can see the point is this. Minus 2, it's 0. Exact this point. Minus 1, it is minus 4. It is minus 4 here. And when x equals 0, it's minus 6. Exactly here. X equals 1, y is minus 6. Write this point, people. X equals 2, y minus 4. X equals 2 is here, y minus 4 is here. X equals 3, y 0, x equals 4, y 6. This point, people, right? We get this way the points. Okay, now we plotted all the points. Now, people, we have to smoothly join this. Right. When we smoothly join these people, this kind of graph coming. We join these people, we can join it like this. Right, like this, we have to join it. This way we have to join. No? This is how you drew this graph. Right? People, this graph is called as what? Quadratic graph. Quadratic graph. The graph of the quadratic function, this. Right? Its equation is y equals x squared minus 6 minus 6. Right? Okay. Now, first draw this graph. People, now in the graph, we'll see some properties. Now you can very clearly understand, people, when we put x value here 5, 6, 7 and so on into this table, and when you find this y value, the y value is, people, increasing. That means this way, this branch, we can draw like this when you put some more x values into the table. From this end, this side we can extend this way, people. Right? So therefore, this graph, the two branches, people, the two branches this way, these two branches go to positive infinity. Positive infinity. But people, this graph has a bottom. The graph does not go below this point. People, the lowest point of the graph, that is this, the lowest point of the graph, that lowest point is called as the vertex of the graph, or people, turning point, vertex or the turning point. Right. Now, I am going to draw a line parallel to this y-axis through this lowest point. Okay, parallel to this y-axis, I am going to draw a line through this lowest point, that is the vertex, through the vertex. That line is, people, this. The line is this, people. That line is this. Okay. You can see this line. People, about this line, you can see something very important. You can very clearly understand the graph cuts the x-axis here and here. People, this line is going between this 0 and 1, exactly midpoint of. This is the origin, no? X0 here. Here x is 1, right? This line is passing through the midpoint of 0 and 1, right? Now this line, people, you can very easily see this line can divide this whole graph into two equal parts, right? This line can divide the whole graph into two equal parts. That you can very easily verify, people. Here, what is the length from this point to this 3? Here half, 1, 2. From here to here, 2.5. The length to this point, people, 1 unit, half, 2.5. Right. And you can very clearly understand, if we consider x equals -1, y is 4. Here, x equals -1, y is 4. And next one, x is 2, y also -4 here. Right. You can see here, when I draw horizontal line through this y equals -4, people, like this here, then you can see from this line to this point on the graph, and from this line, this point to this point on the graph, these distances being equal. Why? Here 1, here half, from here to here 1.5 units, and here see here 1.5. This length is 1.5. So therefore, people, this graph has what? This kind of line. That line can divide entire graph into two equal parts. People, that line is called as the symmetrical axis of the graph. Symmetrical axis, or axis of symmetry of the graph. Okay. So therefore, this graph, now first property is what? This graph has axis of symmetry. That is first property. Right. Now the other thing is, people, you can see this graph has minimum y value among the y coordinates. Among the y coordinates, people, y coordinates mean, you know, these figures. Among these figures, there's a minimum value that is not available in the table. That minimum y value, people, occurring at this vertex. Here, from here to here, this depth, it is -6 point something. We'll calculate that exactly later. Right? People, this is the minimum y value this graph can take. People, what is the maximum y value? At the moment, you might say, this is the maximum height, 6. That is because of people, we took our x is up to 4 only. If we increase the x values like this figure also increasing. Up to what point that y value increase in people? People, that y value goes to positive infinity. So therefore, we can produce this branch to this end and this end. Then you can see the y going to plus infinity. Then maximum value of y, nobody can say. The simplest answer is it is going to plus infinity. It is going to plus infinity. Even though people, we can say this graph has a minimum value for y. What is that minimum value? This value from here to here, right? So therefore, people, this graph is called as a minimum graph. This graph is called as a minimum graph, right? Why is it called as minimum graph? Among the y values, it has one and only one minimum y value. That is this y value. Therefore, the graph is minimum graph. People, this way, minimum graph we get, that you can very easily identify in the function, you know, here, this x squared coefficient is plus 1. X squared coefficient is plus 1. X squared coefficient is plus 1. If this x squared coefficient is plus value, we get always this way, what people? Minimum graph. That is the second property. People, other two properties. Sometimes this graph here, in this case, the graph has cut the x-axis at 2 points, this point and this point. At those points, people, the x coordinates here -2, here 3. They are called as people the roots of the graph. The roots of the graph. Okay, right? Then people, what are the properties? Right. Graph is a minimum graph. How do we identify whether the graph is minimum or any other type? Yeah, using the x squared coefficient. If the x squared coefficient is positive value, x squared coefficient is positive, then the graph is always minimum, right? And graph has axis of symmetry, symmetrical axis it has, right? And what's the other one? Graph has 2 roots. How do we define the roots? When the graph cuts the x-axis at 2 points, at those points, there are people x coordinates. Those x coordinates are called as the roots. Okay, and the graph has the lowest point. This is called as the vertex or the turning point. Okay, this is the vertex or turning point. Vertex or turning point. Turning point. This is the axis of symmetry, people. Axis of symmetry. These x values are called as people roots. Okay, people, now the other thing, this axis of symmetry cuts the x-axis here, no? Here, it cuts the x-axis here. Here we have x coordinate. X value we have. That x value is really half. Because this line passing between exactly midpoint, between 0 and 1, no? Half. Right? That half, of course, we can obtain in another way. Take this root 3 and this root is -2, no, people. Add these 2 roots and divide by 2. Once you add the 2 roots, one root is 3, the other root is people -2. And divide this by 2. What do you get here? 3 plus and -2 divided by 2. Here we get what? Half. Half means people 0.5. So therefore this point is half. Its coordinate is half here. Right? People, then how to write the equation of this axis of symmetry? at every point on this line, when we consider any point, people, the x coordinate is half. So therefore, this axis of symmetry, its equation we write as x equals half. Right. Then people here, this vertex in your O levels, you roughly drew this one in the graph paper, and you roughly found that x coordinate and y coordinate at this vertex. That accuracy of the answer actually depends on the reader and the way you drew the graph. Then your answer you obtain in your O levels is not the accurate one. People, there is an easy way of finding this coordinates of this vertex. People, coordinate mean when we consider any point, here you can see when x equals -3, y is 6. X equals -3, y is 6. So therefore, this point has two coordinates. What is the x coordinate? -3. This height is the y coordinate, +6. Like that, in the OXY plane, if we need to mark a point, people, if we need to mark a point, there we should use two coordinates, x coordinate and y coordinate. People, the x coordinate of this vertex is x equals half. Why, people? This vertex is on this axis of symmetry. We know any point on the axis of symmetry has what? X coordinate half. X coordinate half. Right? Then here to find the y coordinate, this height we have to find. People, to find this height is the y coordinate. That height can be found, people, this way. Now, how did we find this y value when x equals -3? We substituted that x equals -3, we are here, and we simplified. That is how we found this 6, the y coordinate. Like that, people, to find the y coordinate at the point this, since here x coordinate is half, we have to substitute that x coordinate half, we are here, and when you simplify correctly, you get what? The y coordinate at this point. Understand? Right? Okay. So then we can find that also. Before going to that, people, we'll write some properties of this. And thereafter, we'll calculate the y coordinate here. Okay? Then, of course, complete we can draw the next graph by using this idea. Okay? Yeah. Then we'll write a few properties. Now, write down properties of the graph. Properties of the graph. Properties of the graph. Write down number 1. Write down number 1. Graph has only one minimum value for y. Only one minimum value for simple y. Graph has only one minimum value for simple y. Therefore, the graph is called as a minimum graph. A minimum graph. Minimum graph. Write down. The lowest point, on the graph, the lowest point on the graph is called as the vertex, is called as the vertex. Within bracket, write down turning point. Called as a vertex. Within bracket, write down turning point. Right? Because this way, a minimum graph is coming like this, that you can very easily identify at the very beginning by the equation of the given function. If the x squared coefficient is plus sign, x squared coefficient has a coefficient plus, then the graph is people minimum graph. Put the star mark and write down like this. Write down. In the equation of the graph, if the coefficient of x squared, is positive, then the graph is a minimum graph. Right. That is first. We'll write people second one. Number 2, second property. Write down. The graph is symmetric. 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 About a line. About a line parallel to y-axis. This line is called as the axis of symmetry. 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 Right. Right, third one, people. This x coordinate here and here, where the graph cuts the x-axis, are called as what? Roots. Write down. The x coordinates at the points, the x coordinates at the points where the graph cuts the x-axis, where the graph cuts the x-axis. Are called as the roots of the graph, the roots of the graph. The roots of the graph. Right. Therefore, people, the two roots are here -2. This is 3. The two roots of this graph are -2 and 3. Right. Now, people, let's see how to find that equation of the axis of symmetry and the x coordinate and y coordinate of the vertex. Right? Yeah. Then write down like this. Write down like this. The roots, first one put a star mark and write the roots of the graph are. What are the values, people? One root is x equals -2, other one is x equals 3. Right. Now write down here. The equation of axis of symmetry, people, we can obtain adding these roots and dividing that by 2. Okay. Write down the equation of axis of symmetry. X equals, how to take that, people? Add the two roots, 3 plus -2 and divide by 2. Then we get x equals plus and minus make minus, divide by 2. Then, people, we get 3 minus 2 is 1/2. X equals half. Now tell me, people, how to find the exact y value at the vertex. This x equals half, we substitute where in this for x and simplify, you get y. That is the minimum y value. Minimum y value is the y coordinate of the vertex. Right. Then you can write it like this. Write down next star mark, y coordinate of the vertex. Y coordinate of the vertex. Y coordinate of the vertex. How to find that, people? This x value, half, we have to substitute in the equation for x, right? And then we get what? This y equals half to the power 2 minus half minus 6, right? You know, people, half to the power 2 is 1/4 minus 2 minus 6, right? Okay, now we can simplify this. What do we get here, people? Take the common denominator as here 4, right? Here then we get 2, here we get 24, no? Right. So then what do we get here? 1 minus 2 is minus 1, minus 1 minus 24 is minus 25 divided by 4. So this is minus 6.25. Minus 6.25. Then the y coordinate at the vertex of the graph is minus 6.25. So then you can write, people, the vertex, the coordinate, x coordinate is half, y coordinate is, people, minus 6.25, right? Then you can write vertex. Vertex, right? Therefore, the vertex is half, comma, minus 6.25. People, in your honors, when you find this one, you actually obtain this reading and put the y coordinate approximately. But people, we have found that up to 2 decimal places, right? Yeah. So this is how we understand the properties, right, people? Now, next thing. Now, in this case, when this x squared coefficient is positive, it is x squared means plus 1x squared, no? 1x squared, no? Coefficient is, people, plus. Then we notice here, we get this kind of minimum graph. Let's see what happened to this x squared coefficient is minus, right? Then see what is the shape of the graph, right? Then for this one, people will construct another graph. Thereafter, getting this basic knowledge, we can go to what? The risk theories in our lesson, right? Okay. Now come to this one. Write down another example like this. Okay. Write down as a question. Write down, draw the graph of y equals minus x squared plus x plus 2, right? Right. People, now we'll prepare a table. In this case, I take values for x in the table like this. Right. X value here, y value here. Right. Put these values. Minus 2, minus 1, 0, 1, 2, and 3. Right. These are the people, the x values. Right. Now, first fill this table and we'll draw this graph and see its properties. Thereafter, people, we can go to the next part. Right. First, fill this table, people. Right. Now, when you people here, when you put x equals minus 2, then we can find this y, right? x equals minus 2, you can write y equals minus, x is minus 2. Minus 2 perfect square plus minus 2 plus 2. So then what do you get there? Minus 2 perfect square is plus 4. But we have before that minus sign. Here minus 2, here plus 2. This 2 you can cancel now. Then we get y is minus 4. Y equals minus 4. Right? Then we can write minus 4 here. When you put x equals minus 1, right, here we can write y equals minus 1 squared plus minus 1 plus 2. What do you get here? Minus 1 squared is people 1. And this minus sign, it's minus 1. Plus and minus, minus. And here 2. Minus 1, minus 2, plus 2, it's 0. Y is 0. Like that, now you can find the y values. Then we get the people y values like this. Here 2, this is 2, 0, minus 4. See here, in this case, we have x squared coefficient is minus, x squared coefficient is minus, x squared coefficient is minus, right? Right, now we'll draw the graph. When x is minus 2, y minus 4. Minus 4 is here. Minus 2, it's minus 4. Like this. The point is this. X equals minus 1, y 0 here. X equals 0, y 2 here. X equals 1, also y 2. This point, people. This is a point. X equals 2, y 0. X equals 3, y minus 4. Y minus 4, right, like this here. Okay. Now, by smooth drawing these points, people, we can draw the graph here, right? Graph is coming like this now. X equals 3, y minus 4, right now? X equals 3, y minus 4, like this. Here, graph is coming like this. Right, people? Yeah. Now, actually, if we have more x values in this table, then this graph, actually, we could have extended like this. This way it comes, people. Without an end, this goes like this. Then you can see this end goes to negative y direction. Where does it stop, people? No stop. Therefore, we see these two branches going to negative infinity of y. Now, at any point on the graph, when we consider, people, this height from that point, this height to the x-axis is called as, people, the y coordinate of that point. When the graph lies below the x-axis, that y coordinate is negative. Then when the graph going like this, people, you can see that y coordinate, the gap, the height to the x-axis increasing, but having minus sign before that. Then we get like somewhere here minus 10, and somewhere here minus 12, somewhere here minus 100, and so on. You can see people, when this graph going this way downward, people, the y coordinate having minus sign take bigger values, then overall value is what? Decreasing, because they have minus sign before. But people, here on the graph, there is a highest point. Its y value is positive. It is the maximum y value among all the y values available in the graph. Therefore, this graph is called as, people, maximum graph. That is the reason. Maximum graph. This is called as a maximum graph. The reason why, people, among all y values, there is one and only one maximum y value. That y value is occurring at this turning point or the vertex. So therefore, this graph is called as maximum graph. Then before drawing the graph, you can now identify the graph is maximum. That is coming here. X squared coefficient here, people, now minus. If the x squared coefficient is minus, the graph is maximum graph of the shape like this. This graph also, people, have the same properties as we discussed earlier. It has two roots. This time it has a vertex. That vertex or the turning point is a maximum point. And the graph is symmetric. In this case, what is that axis, people? That axis is still the earlier x equals half axis according to this graph, right? So then when I draw this way a line through the vertex, people, here, about this line only the graph is symmetric. The graph is symmetric about this line. About this line, the graph is symmetric. It has axis of symmetry. People, its equation can be obtained as before. You can very easily see that line is passing between 0 and 1. Then the midpoint should be half. Therefore, the equation of this should be x equals half. As I told you earlier, people, that equation can easily be obtained. How? Adding the two roots and dividing by 2. When you add the two roots, what do you get here? Here 2 plus this is minus sign, minus 1. 2 plus minus 1 means 1. Divide by 2, half. X equals half. Right? We get. And the maximum y occurs where? At the vertex. That can be found. How, people? At this point, x coordinate is half. Putting that half here, here, and simplifying this, we get the maximum y value. Then the graph has, as before, the same properties. So therefore, by the summary up to here, people, you have to understand, right? Quadratic graph can be basically two shapes: minimum, maximum. What are the properties? Graph is symmetric about the line which is parallel to x-axis. The graph has lowest point if it's a minimum, the highest point if it is a maximum. That lowest point or the highest point on the graph is called as its vertex or the turning point. And the other thing is, graph can cut the x-axis at 2 points. At those points, x coordinates are called as the roots of the graph. Understand? Okay. And people, this way, we now have some idea about what are the shapes, properties of the graph of a quadratic function. They are very important when you work out, people, the questions in A level. Because if you don't have this idea and when we go straight away to the lesson, people, in the future theories, you can't understand well. Right. And now we have people drawn the graph. Now we'll write some properties. We'll write some properties. Right. So this is, as before, people, the axis of symmetry. I write down them. This is the vertex or the turning point. Vertex or the turning point. These are called as roots, right? Write down, people. Properties of the graph. Write the properties of the graph. Properties of the graph. Write down. Number one, the graph is a maximum graph. The graph is a maximum graph. The graph is a maximum graph. Graph is a maximum graph. Write down. That is among all simple y values, that is among all simple y values, there is only one value for y which is the greatest. Which is the greatest. Right. Write down. Number two, the graph is symmetrical. The graph is symmetrical about an axis passing through the vertex. Write down. Its equation is, people, how to take that? Its equation is at the roots 2 plus minus 1. 2 plus minus 1 divided by 2. X equals 2 plus and minus 1 by 2. X equals half. Right? Okay. Write down. Number 3. First take down this and then write. Write down. The graph cuts the x-axis. The graph cuts the x-axis. At 2 points. The x-coordinates at these points are the roots of the graph. Right. Write down. They are for the roots of the graph. They are for the roots of the graph are x equals -1 and x equals 2. Right, now people, that's all. So then remember here, when this x squared coefficient is negative, right, we get this way a maximum graph. Remember that. Okay, right. Now people, draw in this way the graph constructing a table, we can't apply in A-levels because suddenly when you are given, right, the equation, you should be able to get the graph, right? Now people here, one thing we didn't find, what is that? Y coordinate of the vertex. How to find that? Put in this x equals half, we are here, and simplifying. That also will find. Okay, write down like this. The y coordinate at the vertex, the y coordinate at the vertex, the y coordinate at the vertex. How to find that, people? Y equals minus x squared plus x plus 2. We put x equals half in it. Y equals minus half to the power 2 plus half plus 2 minus x is half. Then we get 1/4. Here half and 2 is, people, 2 and half, no, that is 5/2. Then here we can write common denominator as 4. Here -1. Here, people, we get, we have multiplied this by 2, not 10. Then we get 9/4. It is nothing but 2.25. This y coordinate is, people, 2.25. Therefore, the vertex we can write vertex, you can write half 2.25. X coordinate is half, y coordinate is 2.25. Right. Okay, people, now you can see very clearly here. When we need to draw the graph, we constructed this way a table. People, in our day-to-day mathematical works, usually not the 100% accurate graph we need. We need just what? The graph including the most important properties into that. As the most important properties, we consider these as the most important properties. People, the roots are important and the vertex important. And in addition to that, people, whether the graph is a maximum one or a minimum one, that's also very important. If we can include in drawing a graph, that's much enough, people, very much enough in our day-to-day mathematical works. Okay, then, people, let's see how to draw a graph this way without constructing a table. Right? Yeah. Okay, we, of course, in the first question, we took one graph, that is y equals x squared minus 6 minus 6. We'll take that question also, the same question, people, then you can very easily but understand the same thing coming, right? Yeah. Right on. This is submit in. Second method. right? Method 2. Method 2 of drawing rough sketch of the graph. I will take people this one, y equals x squared minus 6 minus 6, right? This is the very first graph we drew. It's a minimum graph, and you know its roots and all. Yeah, people. Now these are the methods. Now we are not going to construct what the tables. We factorize these people. How to factorize now? Minus 6 we have tried as a product of two numbers, so that the algebraic sum to be minus 1. It is minus 3 into 2. Correct? No? Minus 3 into 2 is minus 6 coming. The algebraic sum going to be minus 1 here. Then we factorize the right hand side first. Then we can write people here this as minus plus 2x minus 3x like this. Then from this 2 we take x out. Then we get x plus 2. From these two terms, people take minus 3 out as common factor. Whenever you take minus sign out, the signs within bracket we must write should be opposite. Meantime, divide each by 3. Then we get x plus 2, no? Then this x plus 2 again, people common. Then we get x minus 3. We know because of the x squared coefficient plus, the graph is a minimum graph. People, we said in drawing what? A graph. What are the important points? Roots and the vertex, and whether the graph is maxima or minima. First part is okay. The graph is minimum, sure. Now we find the roots. People, you know, to find the roots, roots means this x values, no? Those x values. Those points lie on the x-axis. You know, at these points, people, y coordinate is 0, no? Y coordinate is 0. These x values are called as the roots. At these points, people, you know, y coordinates are 0. Therefore, after factorizing like this, people, right, to find the roots, what you need to do is put for this y 0 and find x of the resulting equation, right? Put in y equals 0. What do you get, people, when you put here y 0? This product is equal to 0. Then I am writing that like this: x plus 2 into x minus 3 equals 0. Equate this to 0 and this is 0. Then you can take this to this side. We get x minus 2, here x3. People, see, we got what? The two roots. So the same two roots we got, no, people? Right? Minus 2 and 3 in the first graph. Right. That is okay. Right. And people, we said what? The axis of symmetry, its equation is obtained how? Adding the two roots and dividing that by 2. That x value only x coordinate of the vertex. Then we can write the x coordinate of the vertex by using what? The roots, adding them and dividing by 2. Okay. Then you can write roots, okay. Right. Now, x coordinate, write down. X coordinate at the vertex. How to find that, people? Add the two roots, 3 plus minus 2 divided by 2. We get what? Here minus 3 minus 2 is 1 by 2, half. And we said, people, how to find the y coordinate of the vertex? That x coordinate of the vertex we substitute in for this every x in the equation, right? Then we can write, people, putting that here, x squared minus x minus 6, y coming as half to the power 2 minus half minus 6. And then what do we get? Y equals 1 by 4 minus half minus 6. we get what? Y. Here 4, 1, minus 2, minus 24. What is that, people? Minus 25 by 4 minus 6.25. Then do we know vertex, people? We know the vertex. We know the vertex. We know the vertex. We know the vertex, people. What is the vertex then? Therefore, the vertex. X coordinate is half, y coordinate minus 6.25. Right. Okay. Now we can draw the graph, rough sketch. We need only rough sketch, people. Nobody can draw 100% accurate graph, even though we prepare a table. By the table also, we get rough sketch, people. Right? Now, we know the graph is minimum. We know the roots. We know the vertex. Now, we can draw rough sketch, people. Right? Here. Y-axis. X-axis. Right? The two roots are minus 2 and 3. 1, 2, 3. Minus 1, minus 2. Right? Minus 1, minus 2. The graph passing through the points, this minus 2 and plus 3. Okay? And vertex is half. Half means exactly the midpoint of these two, minus 6 point, right? Somewhere here, right? Somewhere here we have minus 6. Now, people, we can draw a rough sketch. Yeah, graph is passing through this point, and this point. Here, the graph is coming like this. This is a graph, people. This is a graph. This graph is very much enough in our A-level works, right? The same graph you get, people, you drew earlier by using a table. No longer we make the table. This is second method, people. This is the second method. Okay? Yeah. Now we'll come to another graph. It's a maximum one to draw this way, this method. Right? Yeah. Thereafter, we can go to the third method, people. Third method. That is much easier than this. Then after that, people, we have an idea how to draw a graph, rough sketch. Suddenly, as I told at the beginning of the seminar, within 30 seconds, you can draw the graph now. That you can verify after discussing the third method. Okay? Yeah. Right. We'll come to another one question. Right. Come this. Sketch the graph of y equals minus x squared plus 6x minus 8. Minus x squared plus 6x minus 8. Right. I'll give 2 minutes. Just try this question, people. Right. We have to first factorize this, no, people? I'll first take this minus sign out. Y equals minus x squared plus 6x minus 8. No, we'll take minus sign out from the right hand side out of bracket. Then the terms we write within bracket, people must be having opposite signs. No? Then here x squared minus 6x plus 8 coming. Now you can very easily factorize this, no? What are the factors here? X minus 2, x minus 4, no people, the two factors. We have minus sign before this. Right, this time I didn't explain the way of finding the factors. You can very easily manage that, no? Now you can write roots, right? For roots, what can you say, people? Y should be 0. Y is this with minus sign, x minus 2, x minus 4 equals 0. Right. People, this minus sign means minus 1. Minus 1 multiplied by this should be equal to 0. Minus 1 never be equal to 0, no people. So therefore, for this product to be 0, or else we can multiply both sides by minus sign. Then this minus make plus. Right hand side is 0. When you multiply by minus sign, people, we get minus 0. People, no 0 called as minus 0. 0 has no sign. Right? So therefore, when you multiply both sides by minus sign, we get 0 on the right hand side. So this implies what, people? X minus 2, x minus 4 equals 0. Then we get x minus 2, 0, x minus 4, 0. Then by this we get x equals 2, x equals 4. Right. The two roots we found. Graph is maximum, people. Right. Then x coordinate at the vertex, how to find? Add the two roots and divide by 2. Now you can write x coordinate at the vertex or of the vertex also, all right, of the vertex. How to find that, people? Add the roots and divide by 2. It's 3. Then how to find the y coordinate? Put this x equals 3, we are here. Y minus x squared plus 6x minus 8 minus 3 squared plus 6 into 3 minus 8. We get here minus 9, 18 minus 8. What do you get there, people? It is 1, no? This one. Then what are the coordinates at the vertex? 3, 1. Vertex you can write, people. 3, 1. Now this is enough. Since x squared coefficient is negative, graph is a maximum graph. The two roots we found, 2 and 4. Vertex is at 3, 1. People, now you can draw rough sketch, right? You can draw rough sketch of the graph. Right? The two roots are 2 and 4. Here 1, 2, 3, 4. 2 and 4 here. Vertex is 3, 1. X coordinate 3 here. 1, 2, 3, 4. X coordinate 3, y coordinate 1. This way. Now, it's maximum, no? This way the graph. This is the graph, people. See here, in order to get this graph in your level, you prepare the table, mark points on the graph paper, and join them smoothly. People, the same thing, same graph coming. Right now, somebody answer this way. If you need to find this coordinate, Here this point is on the y-axis, no? Any point on the y-axis has x coordinate 0. Therefore, if we need to find out this y coordinate of this point, we have to substitute x equals 0 where here. And thereby you can find out this point. Okay, we'll write that also. This point is the vertex, people, now 3, 1. 3, 1. Right? Point A, suppose we need to find point A, that can also be found, people. Put in where? In this x equals 0 and find in corresponding y value. Right. We'll write that one here. Point A. Point A. Put x equals 0 where? In y equals this minus x squared plus 6 times x minus 8. Once you put x equals 0 there, what do you get, people? Minus 0 squared plus 6 into 0 minus 8. This is 0, this is 0, y is minus 8. Therefore, people, this point A is minus 8. That we found. Right, people, this is the second method of proving that. There is another method, people. There's another method, right? We'll come to that third method also. That is the, people, method commonly we use in drawing the quadratic graphs, right? Yeah. Right. We'll take, people, this as method 3. Method 3. Right. Again, I am going to take the very first question, the minimum graph, to draw using what? The third method. That method is called, people, complete in the square method. So here you should know what is complete in the square, that you have done in your levels, but I'll remind that. Okay, right. Write down method number 3, complete in the square method. Write down complete in the square method. Complete in the square method. Right. Right. Under this complete in the square method, people, I'll explain. Now, suppose like this, we are given something like this: x squared plus 4x minus 3. Right. People, complete in the square mean these 3 terms we can write a perfect square of a linear function in x after the bracket with plus sign or minus sign particular value we have. These 3 terms we can write perfect square of a linear function in x after the bracket having plus sign or minus sign, we have particular value. Converting these 3 terms to this form, people, is called as complete in the square. The reason is here, people, we have perfect square. Square completed there. So that is why this is known as what, people, complete in the square method. Right. These are the steps. Very carefully listen to me. Right. Now, before going for this complete in the square, you have to first check whether the x squared coefficient is plus 1. Definitely, the x squared coefficient should be plus 1. Sometimes, suppose when you are given something like this, okay, x squared coefficient is not plus 1. There we have minus 2. Then first of all, that x squared coefficient minus 2 we have to remove from there, and we have to bring there plus 1. For this, what you do usually, people, the existing at the moment, this x squared coefficient minus 2, we take out from a bracket. Then once you take out this minus 2, the existing x squared coefficient out from a bracket, people, all the terms in this expression should be divided by minus 2. Then what do you get? 2x squared. When you divide by minus 2, we get only x squared. And this 6 we have divided by minus 2, we get minus 3x. And here minus 8 we have divided by minus 2, we get plus 4. Right. Now see here, within bracket, now we have x squared coefficient plus 1. Up to this, we have to convert that given thing. Okay. Right. Now, the steps in completing the square we have to apply for this. Right. Now, let's see what are the steps in completing the square. Right. Yeah. Now, the next step is this. Now, here, x squared coefficient is now plus 1. We have to definitely have the x squared coefficient to be plus 1. Now people open the bracket. Put the square of the bracket. Open the bracket like this. Put the square of the bracket. And the third term, we write next to that minus 3. Right? Okay. Up to here, I think you can very easily understand. Okay. Now within bracket, the terms we write are these. From this x squared, don't write this square, only x, right? From this x coefficient is 4, no? Whatever this x coefficient, divide that by 2. Divide that by 2. When you divide 4 by 2, what do you get? We get 2, people. Here the sign is plus, no? Then we get plus 2. Put that 2 here. Now, what are the terms we write within bracket? From the x squared, without the square, this 2, only this x. Next one, divide this coefficient by 2. Then with the sign, write that. Right. The last step. Square this. Square this. 2 square. What? 4, no? That one you have to subtract. What you subtract? The perfect square of this 2 squared 4, no? That we subtract. That we subtract. That's all. Then simplify this. Y equals x plus 2 perfect square minus 3 minus 4 is minus 7. Now see here, instead of this now 3 terms, we have perfect squared, after that minus sign. This is called as what? The completed the square of the trinomial or this expression. Completed the square. People, once you simplify this, again we get this. How? Let's see. When I people simplify this, this is your A, this is your B. Then you have within bracket what, people? A plus B squared. How to expand A plus B to the power 2? Square of this A squared plus 2AB plus B squared. And then once you square, what do you get, people? Square of this x squared, right? Multiply this 2 and again by another 2. Product of these 2 should be multiplied by 2. What do you get? 2 into x is 2x, multiplied by 2 is 4x. And 2 squared, 4. And minus 7. See, people, 4 minus 7 is minus 3, no? Then see, you get what? This way. The same thing coming. Understand? Right? Okay. Then this is the method. Right. Then we'll come to first part. Write down like this as a question. Complete the square. Complete the square. Complete the square. Complete the square of y equals x squared plus 4x minus 3. Y equals x squared plus 4x minus 3. Y equals x squared plus 4x minus 3. Right. People, come to the steps. Right now. Okay. Second one. Take this one as second. Y equals minus 2x squared plus 6x minus 8. Minus 2x squared plus 6x minus 8. Right. Do we go to apply the steps straight away? No. We have to make always this x squared coefficient to be plus 1. For this at the moment, we have to take that minus 2 out from the bracket. Then within bracket terms can be written down, dividing all the 3 terms by minus 2. Then take first. Okay, now for this one only, people, we apply that steps I explained here. Right, leave that minus 2 out of the bracket. Right, y equals minus 2. Open this square bracket. Now open within that normal parenthesis like this, and then this plus 4. People, what are the terms we write within bracket? From this x squared, only this x, right? And the minus sign is there, no? Divide this x coefficient, it is 3, no? 3 divided by 2. Then we have tried 3 divided by 2 is 1.5. We'll write that as same way 3 by 2. 3 by 2. Now, people, always we subtract perfect squared of this. This sign can be plus or minus. Whatever the sign in between these two we have, the perfect squared of this we always subtract. Always we subtract that perfect square. People, what is the perfect square of this 3 by 2? Square in 3 we get 9 by 2 squared. 2 squared is 4. 9 by 4 we have to subtract. Minus 9 by 4. Right. Now we'll simplify this, people. Y minus 2, x minus 3 by 2 perfect squared. Take here common limit as 4. 4 into 4, 16 minus 9. Right. Now we can simplify this furthermore like this. X minus 3 by 2 perfect squared. And here 16 minus 9, people, really 7, no? Okay, now multiply by this minus sign. Then we get the last stage. When you multiply by minus sign, what do you get, people? Y equals minus 2 times x minus 3 by 2 perfect squared. Here minus and this plus make minus, right? Okay. And when you multiply by this 2, the 4 and this 2 we can divide. 2 and this 4 we can cut. Then we get here 2, then minus 7 by 2. Minus 7 by 2. Yeah. Now, people, will see how to use this completing the square to draw the very first graph today we drew. Right. We'll then come to this. Yeah, write down like this. Using the completing the square method, write down using the completing square method. Using the completing square method, draw the graph of y equals x squared minus 6 minus 6. X squared minus 6 minus 6. Right. People, first of all, give me the completed square expression here. Right. Give me that first. Right. So now here, y, here x squared coefficient is +1. So therefore, we can straight away apply that strips. Put the perfect square and this minus 6. Right. Now, from the square, we write only x. People, what is the x coefficient here? -1, no? We'll put minus sign here. Here 1, no? Minus 1x. Coefficient of x is -1. That 1 should be divided by 2. 1 should be divided by 2 means we get 1/2 like this. Right. Now, what we do, people? We subtract the perfect square of this. 1 squared is 1, 2 squared is 4. Half perfect squared is 1/4. Right. Now, we can, people, write. Right. By this 2, you can take minus sign out. Then we get 6 plus 1/4. Now taking common denominator here as 4, simplify this. Y equals x minus half perfect squared. Here take common denominator, what, people? 4, no? 4 into 6, it's 24 plus 1. Y equals x minus half perfect square. Here we get 25/4. Up to here we came now. Right. Now, people, we are going to draw now. So, you know, what are the important things we need to draw a graph? Vertex, x coordinate and y coordinate of the vertex we need. And the roots we need. I'll tell you how to find the coordinates at the vertex. And you know this graph is, people, what? Minimum graph. The reason is x squared coefficient is here plus. So therefore graph is minimum. First thing we know. Now I am going to tell you how to find the vertex. People, coordinates at the vertex can easily be obtained like this. Can easily be obtained like this. Here, people, the bracket, within bracket, the second number, this one. Okay. Change the sign this to opposite. Then take this value. Here we have -1/2, no? Change the sign this to opposite. Then we get what, people? +1/2. That +1/2 is the x coordinate of the vertex. So therefore, vertex you can write +1/2. How take that one? Change the sign this to opposite and take this number. What is the y coordinate? People, soon after this perfect square, with the sign, take this figure. That is the y coordinate. What is that? -25/4. -25/4 means, people, -6.25. See whether we got the same vertex. We got no. All right. Now in this completing square method, people, though we have used 1, 2, 3, 4, we can take the answer within 2 steps. Once you reach here, you can take the answer. Right. So therefore, vertex we can find. People, how to find the roots? We said to find the roots, the y we have to equate to what? 0. Y we have to equate to 0. And we have to find what? X. Now we'll write roots. We'll write roots. We'll write the roots. For roots. For the roots, y equals 0. Okay. Then you can write in 0 for this y. What do you get? Then this is equal to 0, right now. X minus half of x squared minus 25 by 4 is equal to 0. Bring this to right hand side, people. X minus half of x squared is equal to 25 by 4. Now take the square root on the right hand side, then you have to put plus or minus to the right hand side. X minus half is equal to plus or minus square root of 25 by 4. The square root of 25 is 5 people, that of 4 is 2. Then we get x minus half plus or minus 5 by 2. Take this minus half to right hand side. X equals plus half. When we bring this right hand side, that will be plus or minus 5 by 2. Now take plus sign. 1 by 2 plus 5 by 2. X is 1 plus 5 is 6. 6 divided by 2 is 3. 1 root is 3. Take minus sign separately, right? X equals half minus 5 by 2. 1 minus 5 is minus 4, divided by 2 is people minus 2. Then we know the two roots. People, you know the same roots we got, no? The same roots we got, right? Minus 2 and 3. Now people, we know the two roots. We know the vertex. We know the graph is minimum. Now we can sketch the graph. Right. See here. The graph. The two roots, one is minus 2. Rough sketch, people, right? Rough sketch. We need always the rough sketch. In your A levels, you won't get to draw the graphs in graph papers. Only rough sketches we need in our mathematical works. Right. It's minus 2 here. And other root is plus 3. Suppose that is here. And the vertex is half here, minus 25 by 4. So now we can draw the graph. Rough sketch is this. Rough sketch of the graph is this. This is y, this is 6. So this point only, people, we get half minus 25 by 4. Minus 25 by 4 means minus 6.25. People, if you need to find this point, how to find this point? At this point, you know, x is 0. Put x equals 0 here. 0 squared is 0. Minus 0. 0 minus 0. 0. Only minus 6 we get to the right hand side. Therefore, y equals minus 6. Right. So this is minus 6. Therefore, this point is minus 6. We drew. Right? Yeah. Okay. Now you can use this complete the square method, people, to draw the graph. Very easy, people. Right? No need to construct the tables. Within, I think, 10 seconds, you can complete the square. Then you can determine the coordinates at the vertex within another 5 seconds. Put in y equals 0, you can find, people, the two roots within another 10 seconds. Then how many seconds used? 25 seconds. Within another 5 seconds, you can draw the graph. That is why I said you within 30 seconds you can draw. Right. Okay. Then we'll count another one question. Right. People, this one is the next. Count this question. Sketch the graph of y equals minus x squared plus 2x plus 8. Use the complete in the square method. Right. Take this, people. Take this. Right, people, can we straight away complete the square? No. What is the reason? Reason is here x squared coefficient is minus. X squared coefficient is minus. Then what we do? We have to convert this x squared coefficient minus to what? Plus. For that, what we do? We take this minus. Minus mean, people, minus 1. We take that minus 1 out, or the minus sign we take out. We take the minus sign out. Right. Now open the bracket. I will open the square bracket like this. Once you take this way minus sign out, people, the terms within bracket, when you write, you have to change the signs of these terms. So then this sign now will be plus. This plus will be now minus. This plus will be now minus. Right? Now apply the steps of the completing square for this. What we do, people, there? Y minus. Open the bracket. Put the perfect squared. And the third term only, people, always we write soon after the bracket. And now what we write within bracket? From this x squared, we write only x. And minus sign. Then the x coefficient is this 2, no? Divide that 2 by 2, people. Always this figure, whatever it is, we divide by 2. That answer only we write here. When we divide 2 by 2, what's the answer? 1. We write 1 here. Okay, right. Now finally, we subtract, always we subtract what, people? The square of this one square, 1 square is 1, subtract 1. Right, we got this. Right. Now, don't go to determine the coordinates of the vertex when the steps like this. People, we have to simplify this furthermore. Right, x minus 1 perfect squared minus 8 minus 1 is minus 9. Now multiply by this minus sign. Thereafter only, people, we determine that coordinates, right? Minus and this minus make plus 9. Minus and then this we get minus x minus 1 perfect squared. This is y. Now determine what, people? The coordinates at the vertices, right? Right. Okay. Now the vertex we can very easily decide. What is the vertex, people? X coordinate of the vertex we said what, always we take from this bracket. From this bracket only we take the x coordinate of the vertex. How? Change this sign to opposite. It's 1. Come on, people. Y coordinate is this single value. It is now plus 9. It is now plus 9. Then vertex is 1, 9. Always the x coordinate is taken from the bracket. Changing this sign to what, people? Opposite. Right? Minus, no, then plus. The y coordinate is this. That is okay. Now, secondly, we have to find the roots. Right? For roots, y0, put y0. Put y0 here. Right? What do you get? 0 equals 9 minus x minus 1 perfect squared. People bring this term to this side. X minus 1 perfect squared. Once you bring this to this left hand side, that will be plus equals 9. Now we can take the square root on the right hand side, plus or minus root 9. It is, you know, root 9 is 3, no? Bring this minus 1 to right hand side, plus 1. Right, now select plus sign. X is what? 1 plus 3, it's 4. Take minus sign. 1 minus 3, it's minus 2. X4, x minus 2. Right, people? This is all. Now we know the graph is what? Maximum. Why? X squared coefficient is negative. Right? The roots we know and the vertex we know. Now we can draw the graph. Right? Okay. Rough sketch only, no? Yeah, then we can draw the graph. The two roots are minus 2 and plus 4. Right. Vertex 1 and 9. Graph is maximum. This is the graph. People, if you need to find this point A, suppose, how to find point A? Put x equals 0 here and here. Mentally, you can find, people, that 0 squared is 0, 2 into 0, this is 0, y is 8. This point is 8. This point is 8. This is a vertex 1, 9. See here, rough sketch is this. Right. Now, people, now only I come to the first definition of the quadratic function. So far, we learned what is this, right? Okay. Then, people, the definition of the quadratic function, let's see. Yeah. Then the quadratic function is defined, people, like this. We can define the quadratic function like this. We write commonly, the most common form of writing quadratic function is, people, y equals ax squared plus bx plus c. What are these a, b, c? A, b, c are any three real numbers. We write it like this, no? A, b, c are any three real numbers with a not equal to 0. With a not equal to 0. A, B, C are real numbers. What is meant by this, people? The day-to-day numbers we use are the real numbers, right? And a should not be equal to 0. What if this a is 0? When a is 0, people, when this is 0, 0 multiplied by x squared. When you multiply something by 0, answer is 0, then this x squared term will vanish from the right hand side. No longer x squared term to the right. Then there is no second power of x. Then this function is not a quadratic function. There should definitely be second power of x on the right hand side. For this, there should be a particular value for x squared coefficient. If it is 0, no x squared term. So that is why it is very much important for this a, x squared coefficient should not be equal to 0. This is how we define the quadratic function. People, what can you say about the graph of the quadratic function? Yeah, this graph of the quadratic function can have basically two shapes. When this x squared coefficient is positive, graph is minimum. If this x squared coefficient simple a is negative, graph is maximum. Then what are the other properties? All the properties so far we have learned, people. What are the properties? The graph can have two roots. Graph has axis of symmetry. Graph is either maxima or minimum, right? Graph is symmetric about an axis. All those properties we so far learned belongs to what? This also. So therefore, this is the people, the common way, general way of writing the quadratic function. Is it clear? Right now? And now, people, we write the quadratic function now, right? Put a star mark. We have written down already what? The subheading as quadratic function. So then we'll write star mark. Write down like this. The function defined by y equals ax squared plus bx plus c. Y equals ax squared plus bx plus c. Y equals ax squared plus bx plus c. Where a comma b comma c here belongs to elements. This elements, what is this R? Set of real numbers, right? Set of real numbers. What is meant by set of real numbers? On the number line, all the numbers available are called as set of real numbers, right? Where A, B, C belongs to set of real numbers. This is written, people, like this. This is the R, no? For this R, we write before this another line. This is the notation to denote the set of real numbers. That one only I have drawn, written here, right, people? Where A, B, C belongs to R with A not equal to 0. With A not equal to 0. With A not equal to 0. Right? The function defined by y equals ax squared plus bx plus c, where A, B, C belongs to R with A not equal to 0, is called as the quadratic function. Is called as the quadratic function. Quadratic function is called as the quadratic function. Is called as a quadratic function, right? Okay. Start from new line, people. Right on. If simple a greater than 0, what is meant by this, people? A greater than 0. On the number line, people, 0 is supposed here. The real numbers which are greater than 0 lies on the right hand side of this 0. On the right hand side 0, on the right hand side 0, all the real numbers are, people, positive. Therefore, a greater than 0 means a is positive value. A is what? X squared coefficient. If this x squared coefficient is positive, the graph is minimum graph. And x squared coefficient is negative. How to write a is negative, people? Negative values available on the left of a, no? Any number on the left of 0. Any number on the left of 0, people. Negative. So therefore, if we need to say that a is negative, How to write that? A less than 0, this way. Right now, then we'll write like this. If a greater than 0, if a greater than 0, the graph is minimum and if a less than 0, the graph is maximum. The graph is maximum. Graph is maximum. Right. People will draw very small diagrams, 2 diagrams like this, right? Like this. Here we have a positive case, minimum. Right. Here we have a negative, a maximum like this. This is y, this is 6, this is y, this is 6. Right, people? Okay, now this point, the lowest point or the highest point we call as what, people? The vertex, no? This is vertex. Vertex, right? The vertex is this. Vertex, right? The line passing through the vertex is called as, people, what? The axis of symmetry, no? Here, axis of symmetry. Axis of symmetry, right? Axis of symmetry. Axis of symmetry. People, the x coordinates at the points where the graph cuts the x-axis are called as what, people? The roots. These are called the roots. These are the roots. We can discuss the next. The roots, these 2 roots, no. The nature of the roots. Nature of the roots means, people, right? Nature of the roots mean the 2 roots can have, people, basically in 3 forms, right? Right. People, again, I temporarily switch off, that means close the chat. Right, I'll answer at the end of the seminar to everything, right? Okay, because otherwise my concentration, of course, breaks. Right, I'll answer all the questions after the class, right? So then one by one, keep your answer, a question and produce me, then I'll answer, right? End of the question, right? Okay, now people will see this. Right, people write like this, another subheading, okay? Types of roots of a quadratic graph. Types of roots, write down subheading, types of roots. Types of roots of a quadratic graph. types of roots of a quadratic graph. Types of roots of a quadratic graph, right? Well, this also we supposed to discuss by drawing few graphs, right? Yeah. First graph I take this way, right? This one, see here, as the question write down. Sketch the graph of y equals x squared minus 4x plus 3, right? People, suddenly we can what? Complete the square. How to do this now, people? Open a bracket, put the perfect square plus 3. Here what we write? Write the x and minus sign, divide this 4 by 2. What we subtract? 2 squared, 4 we subtract. Okay, now what do you get? X minus 2 perfect squared, 3 minus 4 is minus 1. What is the vertex? What is the vertex? Here 2, here minus 1. How to find the roots, people? We have to set this y to 0, no? Then what do you get? This y0 mean, people, this will be 0, no? Then I can equate this to 0. X minus 2 perfect squared minus 1 equals 0. Then x minus 2 perfect square, bring this right hand side plus 1 and take the square root on the right hand side. What do you get, people? Plus or minus root 1 is 1, no? Right? Then you can take this minus to the right hand side. X equals plus 2 plus or minus root 1, people, 1. Then x equals 3 when you take this plus sign, right? X equals 2 minus 1, 1. Right? Now, people, we can draw the graph. Right. Rough sketch only, right? Rough sketch like this. The two roots are 3 and 1. 3 here. Suppose 1 here. The vertex is 2 minus 1. 2 is in the middle. Minus 1 here. Right? And the graph is like this, people. Okay, no? Okay, now we have drawn the graph, people. Graph is a minimum. We have drawn the graph. See, 1 minute. I think less than 2 minutes. Right? How was at the very beginning today when you are given this kind of graph to sketch? Even rough sketch in the morning, according to your knowledge? You take a big graph paper, big table, and still you are preparing the table, no? Right. Right. This is okay, people, at the moment. Right. Now you can see the graph cuts the x-axis at 2 points. Yeah, 2 different points. Graph cuts the x-axis at 2 different points. The two roots, one is 1, other one is 3. The two roots are, people, different. One root is 1, other root is 3. The two roots are different. Right? Then in this case, the roots are in real values. They are real numbers. Roots are real numbers. Roots are real numbers. And these two roots are different. So therefore, in this case, we say, people, the roots are real and different. For the word different, we use another word, distinct. Distinct. So therefore, one way of existing roots for quadratic function, roots are real and distinct. Roots are real and distinct. Distinct means, people, different. Okay? Right? Okay. So therefore, first way is that. Then first draw this one and write one sentence putting a star mark like this. Right. Write down first way. Write down. The roots are real and different. The roots are real and different. The roots are real and different. Roots are real and different. Roots are real and different. O, write down. O, write down. O, distinct real roots. Distinct real roots. Distinct real roots. Distinct means people different. Different real roots. This occasion, people, what can you say? Graph cuts the x-axis at two different points. Graph cuts the x-axis at two different points. Okay, write down. When the graph has two distinct real roots, two distinct real roots, two distinct real roots, it cuts the x-axis at two TWO, two different points. Two different points. Two different points. Right. Okay. People will draw another graph. Come this. Number two, sketch the graph of x squared minus 4x plus 4. Sketch the graph of x squared minus 4x plus 4. People complete the square. Complete the square and take this 2. Complete the square with y. X squared coefficient is plus, no? Then we can straight away apply the steps. Right, of x squared plus 4. Within bracket, what do you write? From the square, only x. We don't write the square. Minus, divide the x coefficient by 2. 4 divided by 2 means 2. What you subtract, people? We said always we subtract. What? The perfect square of this number. 2 squared, it's 4. 4 and 4 we can cancel down, we get 0. Y. X minus 2 perfect square. People, what is the vertex? Right. Vertex. Take the sign opposite here, 2, and here now 0. Vertex is 2, 0. 2, 0 is the vertex. Vertex is 2, 0. Right. Roots. How to write roots, people? Put y0. Then y0. What do you get? X minus 2 perfect squared plus 0. No, that means only x minus 2 equals 0. X minus 2 perfect squared 0. This x minus 2 perfect squared mean, people, really x minus 2 into x minus 2, no, that is 0. X minus 2 perfect squared mean x minus 2 into x minus 2. Right. So then what do you get? X minus 2 is equal to 0. Again, x minus 2 is equal to 0. Then we have, people, two roots which are equal now. X equals 2, x equals 2. Graph is a minimum one. X squared coefficient is plus, no? Minimum graph. the roots are equal. The two roots are each 2. 2 is a real number. Therefore, the roots are real. And they are now equal, people. Equal real roots or real equal roots. Equal real roots in this case. People, for the word equal, we use what? Coincident roots. Coincident roots. Coincident roots. Coincident roots. Then the second type is, people, roots are real and equal. That is known as coincident real roots. Coincident means overlap, equal. Then how to draw the diagram, the graph, people? It's a minimum one. Minimum one. Here. Where's the vertex? Vertex is 2, 0. X coordinate is 2, y coordinate is 0. Here. This point is the vertex. Vertex means the lowest point of the minimum graph. Right? Then the graph is like this. So therefore, people, the second type of exists in the roots. Roots are real and equal real coincident roots or coincident real roots. Okay, draw the graph, people. When the graph has this way, real equal roots, people, the vertex of the graph touches the x-axis. The vertex of the graph touches the x-axis. Right? Okay. Write down, draw the graph, and then we'll write. Write down. In this case, the roots are real and they are equal. Write down O. Real coincident roots. 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 Then second type is that. Write down. When the graph has real coincident roots, its vertex touches the x-axis. Touches the x-axis. Right. People will come to the another one more type we have. Right, we'll come to that. Come this one, people, as a third type. Right, the third one, people, this. Write down this. Sketch the graph of y equals x squared plus 4x plus 5. Right. Complete the square and find, people, the roots. Okay, we'll complete the square here. Y. Take the of x squared plus 5. From this x squared, we write only x. We divide the x coefficient by 2. What you do now, people? The square of this 2, it's 4 now, we subtract that 4. Then we get what? Equals x plus 2 perfect square plus 1. Vertex we can write. Change the sign. This 2 opposite, minus 2 plus 1. X squared coefficient is plus, therefore minimum graph. We'll find the roots. Right. Roots. Right. Set y0. We put y0. Then what do you get? This one, this right hand side becomes 0. No? X plus 2 perfect square plus 1 equals 0. Right. Then x plus 2 perfect squared. Bring this 1 to right hand side, people. Minus 1. X plus 2 is equal to plus, so minus square root of minus 1. People tell me how to find the square root of minus 1. Square root of plus 1 is okay, people. 1. 1 no plus minus 1. What is square root of minus 1? Square root means what, people? Square root of 4, you know, plus 4 minus 2, no. Then either we square this plus 2 or minus 2. Finally, we get the same number, this. Then tell me the square root of minus 1. What? By squaring what number we can obtain this minus 1? That number is the square root of minus 1. Here, by squaring plus 2 and minus 2, we get this 4. So therefore, square root of 4 is either plus 2 or minus 2. Like that, tell me, by squaring what number we can obtain this minus 1? People, when we square any real number, whichever it is plus or minus, people, whichever the real number plus or minus, here, minus 3 when you square, what do you get? Plus 9, no? Minus 3 into minus 3, no? This is plus 9. When you square 0, we get 0. When you square 2, we get 4. See here, when we square any real number, what is the answer? Answer is either 0 or positive. 0 or positive. No any real number, after squaring that, as the answer, we get minus value. So therefore, people, this value we can't find. So this value is called, people, imaginary value. Imaginary value. This is imaginary. Since this cannot be found, people, in this case, for this x, we can't find an answer in real numbers because this is not real. This is imaginary. We can't give an answer for this by real numbers. So therefore, we can subject this x, taking this to right hand side, minus 2 plus or minus. This is imaginary. Imaginary. Therefore, this time we say, people, the roots are not real. Why? This is not a real number. We can't give an answer by real numbers for this. So therefore, the right hand side completely we can't determine by a real number, even though we have real number here. Since this is not real, we say what? The roots are not real or imaginary. Right? Therefore, we get roots are imaginary. Roots are imaginary. Roots are not real. Roots are not real. Roots are imaginary. Roots are imaginary. Roots are imaginary. Then see, people, how to draw this without having the roots. We can draw this. What is the graph, people? Graph is minimum graph. What is the reason? X squared coefficient is plus 1. What is the vertex? Minus 2 plus 1. Right, minus 2 plus 1 is the vertex. Right. See here, people, the graph is this. X coordinate is -2, y coordinate is 1. The graph is like this here. The graph does not cut the x-axis here. Graph does not cut the x-axis. When the graph does not cut the x-axis, people, how can you say the x-coordinates at the points where the graph cuts the x-axis? We can't find. We can't find. Right? So in that case, we get as roots are not real or imaginary. In that case, people, graph does not cut the x-axis. If the graph is a maximum one, the graph completely lies below the x-axis. Understand? Right? Then draw the graph and we'll write that sentence. Right, people? Write down after drawing the graph like this. Write down in this case, graph does not cut the x-axis. Graph does not cut the x-axis. It lies completely above the x-axis. It lies completely above the x-axis. It lies completely above the x-axis. Completely above the x-axis. Right now, people, these three situations, when we explain by using maximum graphs, how to draw maximum graphs to illustrate two distinct real roots, coincident roots, and imaginal roots. For a maximum graph, people, we can illustrate these three cases by drawing the graphs like this. Write down under that. Write down. For maximum graphs, the three types of roots, can be shown by the graphs as follows. By the graphs as follows. Right, people? Simple diagrams, right? Very simple diagrams like this. Here, maximum graph cuts the x-axis at two distinct points. Distinct real roots. Right. The vertex touches the x-axis like this. What is this, people? Coincident real roots or real coincident roots. That's also correct. Real coincident roots. Real coincident roots equal, right? The next one is, people, what? Imaginary roots. Imaginary roots. The roots are like this. Right? Imaginary roots. Imaginary roots. Right? You can write graph does not cut the x-axis. Graph graph lies completely below the x-axis. Complete below the x-axis. Right now? Yeah. So therefore, people, as a summary, can you tell me what are the 3 types of existing roots for a quadratic graph? Yes? Real distinct roots, real coincident roots, and then imaginal roots. Understand? So they are the possible types. They are the possible types. People write down. Putting a star mark. Therefore, a quadratic graph can have its roots in 3 forms. Number 1, people. Real distinct roots. If you draw corresponding graphs, what are the graphs? Yeah, this way, people. The graph cuts the x-axis at 2 points. This way. Number 1. Number 2, real coincident roots. Graph touches the x-axis at its vertex like this. Y and this is x. Right? Next one, people, imaginary roots. Third one is the imaginary roots. Imaginary roots. Then if the graph is a minimum graph, it lies above the x-axis. If the graph is maximum graph, it lies completely below the x-axis. Completely below the x-axis. Like this. These are the ways of existing the roots for a quadratic graph.